Hey Avon, so this is going to be the second part of respiratory structure and function. We just finished talking about the larynx, which houses the vocal cords, and now we're going to move into the true lower respiratory tract. So the trachea, also known as the windpipe, is what's going to take air from the nose or your mouth, if you're a mouth breather, and take it all the way down and into your lungs in order to exchange the gases there. Now, this descends anteriorly to the esophagus. So what that means is that you can actually feel your trachea here. So we've got the larynx, which is going to be higher up, and you can hold your hand there, and if you talk, you can actually feel that vibrate, which is the true vocal cords moving back and forth. And right beneath that is the trachea. And if you move your hand up and down, you might be able to feel some bumps. So the trachea, and this point is saying that, is anterior to the esophagus. So the esophagus is right behind the trachea. So it's not like you can go in and touch and feel the food moving from your mouth down into your stomach. No, but you can feel the trachea right there with its little C-shaped rings. So the lining of the trachea, and this is on the inside of the trachea, we're going to have a ton of pseudostratified epithelial cells with cilia on the top of them that are also going to be secreting a ton of mucus in order to trap any foreign particles or like pathogens in there. Now the cilia have this like esculatory, which is like an escalator function, which helps sweep up any of that debris and gunk up and out past your larynx, and normally people just end up swallowing that mucus, which is really gross, but it's what happens. Humans are disgusting, right? And that will end up freeing your lungs of any of that gunk and debris so that you don't end up getting a ton of crud down into your lungs. Now, if a person smokes cigarettes, whenever they take that puff, the cilia are actually going to become like numbed from that and aren't going to be functioning anymore. So a couple hours afterwards, once they start to wake up, then they're going to see that there's a ton of debris and they're going to kick it into hyperdrive and try to sweep all of that crud out. Now what's going to end up happening is that person is going to feel a ton of debris and gunk, and so they're going to start coughing a ton. And that's what contributes to that like stereotypical smoker's cough. Unfortunately, the first thing they do once they start having that smoker's cough is go and reach for another cigarette and then just start puffing away again. And that's going to immediately put them back to sleep, and then they're going to have even more gunk and debris in their lungs. So, be safe, be smart, make good decisions. Just don't smoke, especially now. Oh my gosh. So, the trachea, because it's putting air into and out of your lungs, we want to make sure it's always, always, always open. And that's where we end up having these C-shaped rings that wrap around kind of like a little cuff here all the way down. And that's going to make sure that the trachea stays nice and open so you can always have airway. Now it's kind of cool. The C is a C. It doesn't go all the way around because remember the esophagus is directly behind the trachea. And so if it went all the way around, then chances are you would have food bumps or bumps for your food to hit whenever you swallow. And so because it is a C shape, it makes that back nice and smooth so it's easy for food to slip and slide all the way down into your stomach. Now, after we go from the trachea, we're going to move into the bronchi. Now, there's going to be a ton of stuff on this slide. All I need you to know is that we go from trachea to bronchi and then eventually into the alveoli, which is where gas exchange is going to happen. So the branching tubes that go from the trachea to the lungs are called the bronchi. Now, bronchi is plural because it's got the I at the end. So a singular tube is going to be called a bronchus. So in the beginning, we have the trachea, and then we split into the right and left primary bronchi. And you can see this in the picture behind my little video there. So we've got the left primary bronchi, and we've got the right primary bronchi. Oh, I'm sorry, bronchus, because it's singular. Left primary bronchus, right primary bronchus. If we want to talk about the bronchi in general, then it's bronchi because there's more than one. From there, we go into the secondary bronchi, tertiary bronchioles, terminal bronchioles, respiratory bronchioles, alveolar ducts, alveolar sacs, alveoli. If you go into anatomy and physiology in college, you will likely need to know that then. But for this class, I don't need you to know that. All I need you to know is that we go from the trachea to the bronchi and eventually into the alveoli. Now, as we move down and into the lungs, we lose cartilage, and that's going to be replaced by smooth muscle. So in the beginning, there's a ton of cartilage in order to force that airway open so that no matter what, it will not collapse on you. But as we move down and into the lungs, we're going to see that cartilage get switched out for smooth muscle so that we can either dilate or constrict those airways depending on your metabolic demands. If you're exercising, chances are the bronchioles are going to dilate so that way you can get more air into your lungs, and it's going to be easier for you to get oxygen to your muscles so you can continue to run or exercise. Now, this is kind of gross, and it's also sad because this person is no longer with us. This is from a 36-year-old man that had a really awful heart failure. And typically when someone has heart failure, just like how if someone has heart failure, they're likely going to have kidney failure, this person also had issues with their lungs. The blood was backed up, and it ended up filling the bronchial tree, which is like all of the bronchi, primary bronchi, secondary, tertiary bronchi, respiratory, all of that stuff. So the blood flowed back into the bronchial tree and then coagulated, leaving this blood clot. He coughed, and this whole thing came up. Now, this is disgusting. This is also very sad because this meant that this man was not able to use his entire right lung. You can tell that this is the right lung because when laid out, this is where the trachea would be, and then it would split off into the right primary bronchus, the secondary bronchi, and then going into the tertiary and eventually the terminal ends, which is where those alveoli are going to be. So while this is very sad, I think it's kind of interesting because you can see the perfect outline of the bronchial tree for that man. So this is essentially what we saw right there. Yeah. Okay, so alveoli reminds me of ravioli. Alveoli are where the gas exchange is going to happen. This is, so remember, we've got the cardiovascular system and blood flow. We go into the right atrium, down into the right ventricle, and it pumps up and out into the pulmonary artery, and it goes to the lungs. So that blood is going to the lungs, and then it goes into the alveoli, and this is where it's going to pick up oxygen and get rid of carbon dioxide. It is made of simple squamous epithelial tissue, so you might remember simple meaning one layer, squamous being squished or flattened, and that's going to allow for diffusion to happen in between the outside environment and your capillaries. So the basement membrane is going to fuse the alveoli and the capillaries together so that we can have that good gas exchange and get the oxygen to your body. So you will see this diagram again, hint, hint. I want to point out a couple of things. In the bronchioles, we have air. We have a pulmonary artery. We have a pulmonary vein. Now, of course, the pulmonary artery and veins are going to be a lot bigger, but this is just going to help show what's going on when it comes to like the alveoli. So the pulmonary artery is carrying deoxygenated blood. It goes to the alveoli. The alveoli are exposed to the air at this point in time within the bronchioles and eventually getting into the alveoli. Oxygen is going to flow into the blood. Carbon dioxide is going to flow out of the blood and into the air. And then the oxygenated blood is going to leave via the pulmonary vein. So we have air within the bronchioles and the alveoli, and we have blood within the artery, capillaries, and vein. Good to keep that in mind. So then the lungs. This is going to make up a majority of your thoracic cavity. We have the mediastinum, which is going to be this little space in between, and that's where the thymus and the heart sits. And we have the thoracic cage, which is going to surround it. Now, the thoracic cage is primarily composed of the intercostal muscles and the ribs themselves. And it is a very controlled, tight space. This thoracic cage, its shape and its size is what's going to determine whether you can inhale or exhale. So ventilation is primarily determined based off of this thoracic cage as well as the diaphragm beneath it. So the diaphragm, you might be able to see, it starts down here and then it kind of goes up and then it falls back down. Your diaphragm looks like a frowny face, and that's going to be really important for what we're going to talk about next time I see you. So the diaphragm, being a frowny face, is a muscle, just like any other muscle. So if I'm looking at my brachialis here, not that it's really defined or anything. But the brachialis is only going to be able to contract. It can only contract. Muscles can't push. Remember, they can only pull. So with your diaphragm here, it can only contract and get shorter. So we're going to have a diaphragm that is relaxed, looking like a frowny face. And then when it contracts, it's going to flatten out. No. No. Sorry, Spanky wants to go outside. So it is suspended, the lungs are suspended by bronchi and the blood vessels, kind of like how the heart is suspended by the pulmonary artery and the aorta. It all just kind of like dangles from all of this stuff up here. It is covered by the visceral pleura, which is going to fold back into the parietal pleura. And this is where we're going to end up having a ton of like serous or watery fluid. And that's going to help make sure that there's no friction whenever you inhale and exhale. What I need you to know, and what's most important that we're going to talk about later on, is that the thoracic cage is essentially like defined by the ribs and the muscles in between the ribs, which are the intercostal muscles, and the diaphragm, which sits like a frowny face and then can flatten out. Your right lung has 3 lobes, 1, 2, 3, whereas your left lobe has 2 lobes. I'm sorry, not lungs. So the right lung has 3 lobes and the left lung has 2 lobes. And you guys might be able to guess why that is. And it goes back to the heart. The heart bulges out to the left. And so there's not as much space on the left side as there is on the right. So the left lung only contains the 2 lobes, whereas the right lung contains the 3 lobes. So that is essentially it. The lungs are made up of alveoli, just kind of like how a kidney is made up of a ton of nephrons, and the alveoli are where gas exchange is going to happen. The lungs are very spongy, and they are going to expand and contract, and that's what ventilation is, which is what ultimately gets air to your alveoli to exchange those gases, getting the oxygen in and the carbon dioxide out. If you guys have any questions, feel free to reach out to me via email or Schoology. I will also have my regular Zoom meetings, so feel free to get in contact with me any of those ways. Stay safe, stay healthy, and make good decisions, you guys. I'm sure I'll see you around.